Very good evening, all of you. Hope you all are doing well. Let's start with today's session. Just a quick recap of last session. In last session, we discussed about primitive data types, right? We saw the ranges, how much size those data types take, and their range, right? The minimum value, maximum value. So we discussed about integer data types, byte, short, int, long, 1 byte, 2 byte, 4 byte, 8 byte. How to calculate their range, all those I told you last time. Then char data type, 2 byte Unicode, then floating point data type, in which in that we saw float and double. So float is for approximate 6-digit precision, double for 15-digit precision. It takes 4 byte, 8 byte. How they are stored in IEEE notation, right? How the storage is done using Mentesa exponent. That also we discussed, isn't it? And then we started with what are variables, variable declaration, variable declaration and initialization. Okay. Continuing some more things related to that, related to variables only. Like today we'll be discussing about variable types depending on their scope. Okay. Just to recap, I told you what is variable declaration and very two important terms in the last session we discussed that Java is a strict type language, okay, and Java is static type. So I hope this both terminologies are very much clear that Java is static type and Java is strict type. Now, why we should say Java is static type? Because in Java, you cannot use any variable without its declaration. First, you have to declare the variable and then only use it. And declaring means what? Telling the type of the variable, right? And name of the variable. Okay. So that that much amount of memory will be reserved for that variable. So in short, the type of any variable is decided at compile time only. Therefore, it is called static type. So always remember, any language which is called static type means in that no variable can be used without declaration. The type of that variable is to be informed at compilation. And strict type means variable cannot change its data type timely. Once it is declared with that data type, throughout its life, it is of that type only. Throughout its life, it will be of the same type. Means if it is declared integer, then its whole scope, it is integer. It cannot change its type. So languages in which the variable can change its type timely, they are called as loosely type. And in which there is no concept of declaration, they are called as dynamic type. So Java is totally opposite of it. So all these things we have discussed. Then I told you the declaration syntax. First you have to give type, is it? Then you have to give the name of the variable, okay? And I told optionally you can initialize also with some value. If you want, you can give some initial value to it equal to value, right? And I told you this thing also that this type can be primitive type also as well as non-primitive. And we have discussed about both this thing. What is primitive, non-primitive in the last session? Non-primitive means they are objects. They store reference. They are vector type. They are group type. They are multi-valued. Getting? They are not single value. They are user defined. Okay. And primitive means built in. They are scalar, single value, elementary type. Okay. They are not objects. So this type can be primitive also, non-primitive. Then the name of the variable and optional. If you want to give some initial value, you can give. Okay. So last time we discussed about primitive declaration. Then same way you can have non-primitive declaration also. But only the special thing about non-primitive, that is object type, is that in Java, every object is a reference variable. It will hold reference. It will not store directly value. Getting? So if I'm creating a variable of type cat. Now cat is obviously not primitive. Why? Because it doesn't come under 8 primitive category. That is byte, short, int, long, float, double, char, boolean. In that category, it is not coming. So obviously, it is user defined. We have created a class cat and we are creating a variable of it. So when you create a variable of any non-primitive type, which is called as an object type or ref type, it will always contain reference. So when I say cat money, actual object is not created. Instance is not yet created. How much space that cat will need? Getting? Whether it will need 8 byte, 4 byte, it depends on the properties in that cat. Its ID, then the name of the cat, then the breed of the cat, weight of the cat, color of the cat. So based on that, the memory is allocated, but that is not yet allocated. Only the declaration is done. Means only a reference variable with the name money is created. And unless and until you create an instance, which we create using new, the space is not allocated. And then only the reference will come. So you have to write money equal to new. Okay. New is the operator which is asking to the VM for space on the heap. So it is just doing a request to virtual machine that please allocate space as much is needed for one cat object. Okay, internally it will call constructor, what constructors are. We will be learning all these things when we will come to object-oriented programming in Java. Okay, so what will happen is on heap, it will allocate space as much as needed for cat, like cat height, cat color, cat breed, cat name, whatever it is. And then the reference will be stored in this money variable, which is on the stack. Getting? And these two things you can combine also. My cat money equal to, and there only you can write new cat. Okay, so this thing you have to remember. See here. So object reference variable means like normal variable only, like you create integer I or float j. Same way, you are creating a variable of non-primitive type. Only it is not primitive, non. And the speciality of non-primitive variables are they don't hold actual value. They hold reference. Okay. And when we get reference, when we create an instance is created using new only. Okay. So in Java, objects are created using new keyword. New is a operator provided in Python, sorry, in Java, and new is requesting to VM that please allocate space on heap. It will reserve that much space and it will give you reference, and that reference you'll store in your reference variable, which is only called as object reference variable. Okay. Then a variable that stores the reference of an object is called as object reference variable. So in Python, sorry, in Java, just remember object means only reference and reference means only object. Correct? Means whenever in Java you're saying it's an object, make sure it is having a reference. It is not containing directly value. Okay? And we do it in this way. The syntax is like that. The name of the class, which is the type, non-primitive type, then your object equal to new, then the name of the class round bracket. So here what happens? New is the operator requesting to VM, please allocate how much space as much is needed for one object of this class. It will reserve that space. Internally, it will call constructor, which will initialize it to default value. And then it is returning the reference, which we store in our reference variable. And the reference variable means only object. According to Java, object means reference variable. And if it's a reference variable, it is an object. That relation is there. Okay. So I hope this part is clear. Now you can do multiple declarations and multiple initializations also. And they both are applicable for primitive as well as non-primitive. Getting? Means you can do declaration of the same type more than one. Getting? Like I'm declaring x comma y comma z. So I'm declaring how many variables of the same type? Three variables. X, Y, Z are three variables of int type. So this will be called as multiple declaration. Declaring more than one variable of the same type. And then you can initialize them also by using one assignment statement like x equal to y equal to z equal to 10. This is called as multiple initialization. You are initializing the same value to multiple variables in one assignment. 10 is stored in z, z in y, y in x. Okay. And this thing which I have shown on primitive is applicable for non-primitive also. Okay. Only if you want to initialize this all declarations with 10, here you cannot do like that. Here you have to separately assign equal to 10, equal to 10. Here you cannot write a int x comma x equal to y equal to z equal to, not like that. Correct? You can do multiple initialization with the same value afterwards using this statement. It is okay. But if you want to initialize with the same value at the time of declaration only, then separately you have to assign equal to 10, equal to 10. Okay. And the same principle is applicable for non-primitives also. Correct? Like if you have class cat, okay, and I'm creating one variable money of cat and another of variable kitty of cat only. So this is multiple declaration. Money and kitty both are reference variable or both are objects of class cat. Objects are not yet instantiated. But suppose guys I write money equal to kitty equal to new cat. So two objects are not created. Object one only, but both are referring to the same object. Correct? Means what will happen? New cat. It will create one object on the hip. Then the reference is stored in kitty. And then the same reference is copied in money. So money will also contain the same reference. And both the objects will be referring to the same place. Means this object is actually having two reference count. So unless and until that ref count becomes zero, this object is not eligible for garbage collection. Correct? Here remember, money equal to kitty equal to new cat. Actual two copies are not created. One copy created, its reference copied in kitty, and the same reference is copied in money. Therefore, both are referring to the same object. Okay, so this concept also you remember that you can do multiple declaration and multiple initialization. As an example for primitive, I have shown. For primitive here I've done, like I've created three variables of the same type, int a comma b comma c. So this is multiple declaration, more than one variable of the same type declared. And then you can do initialization also. Like if you want to initialize multiple variables with the same value, then you can do this in single statement. 10 copied in C, then C copied in B, B copied in A. And the same thing you can do it in this way also at the time of declaration. Similarly, you can do it for reference variables also. Like here, just check employee E1, E2, E3. Only three reference variable because they are variables of employee. Employee is not primitive. It is a class name, user defined. It is non-primitive. Therefore, sure, it will contain reference. Okay. So employee E1, E2, E3. These are three reference variables of type employee. They are not going to hold reference currently when you do initialization. Now you're creating one copy of employee class. Okay. You're creating one object of employee class. Now, as much memory is needed for employee, like employee ID is there, name is there, salary is there, designation, department, whatever. So total memory allocated, the reference come in E3, the same reference is copied in E2, the same reference is copied in E1. So there are three references to the same object. Means you can say they are like aliases. Aliases are there, like your original name, official name is there. Then your friends call with some different name. Your grandmother calls with different name. Your favorite person calls with different name. So what are they? They are just different names for same entity. Here also same thing. For one object only, we are having three references. So you can access the same object with any of these three references. Okay, so there will be three ref count to this object. Unless until the ref count becomes zero, the object is not eligible for garbage collection. Get it? I'll just show you pictorially. That is stack part and the heap part. On stack, one reference variable E3, then the object is created. Then the same reference is copied in E2. The same reference is copied in E1. All three are referring to the same object. Okay, so I hope this concept is clear to you. Okay, now you'll say if you want three different copies, then three instantiations you have to create. Three times you have to write new employee. E1 equal to new employee, E2 equal to new employee. So three copies will be created. And all three references will be stored in three different reference variables. Understanding? Clear? Now, please remember in Java, object means only reference variable and reference variable means only object. It's not like C++. In C++, objects can be created on heap also and stack also. This is not the rule in Java. In Java, all objects are created on heap only. Correct? And if you want to create a reference variable, but currently you don't want to store any reference in it, then you can assign null also to it. A reference variable can also contain null. It is legal. Okay. So this part, I hope it is clear to you. Just give me quick confirmation. At least confirmation I need from your side. Okay. So please unmute and please answer. Is there any doubt in the current explanation, whatever I gave? Okay. So please tell me that.
Yes, sir. Got it, sir.
Sure. Okay. Now moving to the next very, very important topic. All these are basic things. These are all elementary concepts for Java programming. Okay. And if these all concepts are clear, you can very easily appear for Sun certifications also. Okay. I will be really happy if you people are appearing for Sun certifications also at the end of course. Sun certification will really create an impact in your resume. Getting? So, but obviously in 199, I cannot provide that. You have to buy Sun certification coupon separately and you have to appear for that exams. My work is to make you ready for those exams. Okay. Now, next very important topic we have to dive into that is the life of a variable. Okay, the lifetime of a variable, or you can also call it as a scope of a variable. If you have studied Java or Python, or there also the similar topic is there. Okay, so lifetime of a variable means what? In simple terms, you can say the scope of the variable or the part of the code or the section of the code in which the use of that variable is legal. Where the use is legal, we'll call the variable is within the scope. And from any point onwards, from at any point onwards, you're not allowed to use that variable. Means we say it is out of the scope. or the scope is over. So generally scope means section of code in which the use of variable is legal. Correct? The usage is legal or no, that is decided by scope. Now in Java, it is very simple to understand what the scope is. So in Java, when the variable is created, means when it is getting memory, when it is destroyed, means the memory is released, and where it occupies space, that decides its scope. Means accordingly, the lifetimes are changing. Okay, so when created, when destroyed, and where they are occupying space. In philosophical way, I can say, which my teacher taught me, that when the variable is born, if you relate to human life, when it is born, when it is died, and where it is enjoying its life. Correct? So what I'm saying, when created, so in real life we can say born. Okay, when they are destroyed, okay, when they are destroyed, little disturbance is there from my side because upstairs, flat above me, they're doing renovation work. I've already complained that. Now they're saying, please wait for 5-10 minutes. So I hope we will bear that. So created, in short, you can say born. When they are destroyed, okay, destroyed means when they die, and where they are enjoying their life, means where they get space. Okay, so this is when created, when destroyed, and where they get the space. Based on that, there are three different types of variables in Java. Correct? Exactly three. There is nothing other than that. In Java, there is no concept called global. Remember, you cannot do anything outside of the class. So no concept of global. There is local variable, instance variable, and static variable. Only three. Okay. You have to just remember in Java, you will have a local variable, instance variable, and static variable. Okay. So what are the three variables identified by? So as I said, all three will be defined on, all three will have their life journey different. Means when instance variable is created, when it is destroyed, and where it gets space will be different for local variable and will be different for static variable. Okay. So one by one we will discuss. Just remember, whenever you are running any program, okay, so your bytecode for execution will come from this to main memory. So VM will allocate space for it. That is the job of VM. That is your runtime environment contains library plus VM. So job of VM is to provide space. So it will allocate space, okay, for your program. Now, how much sections are created? So remember, there is one section called as stack. Okay. And as the name stack, it will follow its peculiarity. That is, it will be closed from one end. From this side, it is closed and open from this end. Okay. So as it is a stack, it will follow LIFO concept. Last in, first out. Who has gone last will be the first one to come out. Because close from one end, open from other end. And from where it is open, from there only you can add or remove. You can remove or add from that end only. Then we have hip. Okay. Then we actually have a data section, but many books say this data section is along with the code only. This is your code section. Code section will contain the bytecode. Whatever code you want to execute, that bytecode you bring from this to main memory. And then VM will line by line convert this bytecode to machine code and give it to the CPU for execution. And along with the code only, there is one section called data section. Get it? Remember, in all these three sections, variables are there, no code. Your logic, whatever for loops, while loops, if else, switch case, calculations, whatever you have written, their bytecode is in the code section. Code section contains only code. But whatever information you are processing in your code, like you have created variables, arrays, getting all that are in any of these three sections. Okay, so remember, these three sections are only for variables, different type of variable, either local variable, static variable, or instance variable. Getting, but variables, no code will be allocated in this section. For code, there is a separate area called code section. So remember, based on that, only three types of variables are there. So some variables who get space on stack, they are called as instance. Those who get space on heap, they are called as, sorry, I told wrong. Those who get on heap, they are called as instance. Those who get on stack, they are called local. And those who get at the time of code loading, they are in the data, that is static. So for static, data, for instance, heap, and for local, stack. Okay, so all this in detail, one by one, we will learn. Don't worry, I'll tell you everything about it. But from interview perspective, you should remember when they ask like, what is the difference between a local variable, static variable, and instance? 3 points you have to remember. They are all three are characterized on what basis? On the three things. One, when created, when destroyed, and where they get space. Okay, just wait, guys. I'll try to tell them that please stop this. हेलो अभी बताओ ना उनको जरा काम कितना आवाज आ रहा है मेरा क्लास भी पूरा भी हाँ, कोई भी नहीं आया अभी तक वो कंटिन्यूस उनका आवाज चालू है क्या अभी लेक्चर भी रोज तो थोड़ी मैं बंद कर सकता हूँ लेक्चर ओके ठीक है सॉरी फॉर इंटरप्शन गाइस so how we will decide the lifetime in Java when it is created when it is destroyed and where it will get space. Okay, so when the variable is created, when it is destroyed, and when it gets, where it gets memory. So I just told you, either it will get memory in the stack section or in the heap section, or it will get memory in the data section. Many books don't specially clarify that it is a data section. They say along with the code section, along with code section, like this. Whereas in some books, they have clarified that it is a separate area called data section. Okay. And as I said, when they will be created and when destroyed, we will one by one discuss. Okay. So see here, based on lifetime of variable, that is the scope, there are three types of variables in Java. One is the local variable, instance variable, and static variable. Okay. So static variable we have, instance variable, and local. Nothing other than that. Remember, in Java, you cannot have a variable other than this three. Okay. Only these three types of variables Java is having. Okay. Now we will discuss all three in detail. First one I'm going to talk about, that is instance variables.
Sir, is it possible to bring back the last screen one time?
This one or before this?
The before one. Yeah.
This one. Whenever you think like it's important, you can take a screenshot, or you're
Yes,
not
I
able
wanted to
to,
screenshot. Yeah.
if you're not able to note down along with my speed, so it's okay. You can take print up. You can take a
No, after
screen
this one. This is I have taken already.
before this
Before.
also.
No, this, after this one, the lifetime of variable.
This one, no?
Yeah.
Okay.
Yes, thank you, sir. Done.
Okay. Moving to this three types, all these three types in detail we will discuss. And please remember, this is very primary thing because when you move to big codings and all, that time these all things are very elementary part, foundation it creates. First one is that is instance variable. Okay. Instance variables means variables which are belonging to the individual object. Means as many objects you create, every object will have its own copy of these variables. Correct? So what you'll remember, instance variables means variables which belong to each instance. And instance means copy of the class. Copy of the class means object. All similarity term. You have a class. Once you create a class, you create copy of that class. Means you create object of it using new. So when using new, you create a copy. We say we create an instance. Okay, or we are creating an object, and every object is going to have every object is going to have its own copy of this variable. Correct? Why? Because it wants to store the state of each object. So though each object is sharing the property, but the values of that property will be different. Like there are two cats, Money and Kitty. Both are having height, color, weight, breed. Okay. But the height of both the cat can be different. Color can be different. Weight can be different. Breed can be different. So I want to store the state of that object. And every object state will be different. Therefore, it is to be kept in separate copy only. So always remember instance variables are variables which are belonging to each instance or each object separately. They are never shared. Instance variables will never be shared. Okay, they are existing separately in each object. Okay, that is the speciality. Now, first of all, where they are declared inside the class body, but outside method. Class cat, suppose I'm writing. So inside the class body, okay, but outside methods, like if you're adding a lot of methods over here, so not within the method, outside method, inside class body. Means here you are declaring integer weight or string color, okay, whatever. So whenever we are declaring any variable inside the class body, but outside method, then they become instance variable. Okay. Here you can add access specifiers like public, private, protected. Okay. Remember, your static word is not there. When there is no static word, means it is instance. You can add access specifiers like public, private, protected, but we will be discussing about that later. Okay. Now, don't worry, don't assume like C++ that if I don't write any access specifier, then what it will be. Will it be by default private like C++? No, here it is by default default. Means in Java there are four levels: private level, protected, public, and default. When no keyword, it is called default. But that level is separate. Four levels are there. So in detail about that we'll be talking. Now just remember any variable which is declared inside the class body but outside methods. Like maybe here you have created one method void meow. Okay. So outside that method, I'm creating the variable, but inside the class body. Okay. No static word is used. Then they all are called instance variable. Okay. And they are separate for each object. They are not shared. Every object will have its own copy of instance variable. Correct? Means later after the class cat is created, I created one variable money, one object kitty, one object piku, one object bokya. So as many objects I'm creating, everyone will have its separate copy of weight and color. Weight, color, breed, weight, color, breed, weight, color, breed, separate copy. Because everyone wants to store its own state. So they are to be kept separate. Getting? This part is clear. Now, already I have mentioned in the previous slide how they are identified, when they are created, when they are destroyed, and where they get space. Isn't it? So remember, instance variables are created when you create an instance of a class by using new. When you create any instance of a class, that time the space for instance variable is allocated. Means they are born. You'll say they are born now. Okay? Birth of that variable. Now you'll say till when they are available. Till the reference of that object is not lost. Means till the object is not eligible for garbage collection. And when the object is eligible for garbage collection, when the ref count of that object becomes zero. Correct? Like you have one reference variable which is referring to one object. Okay, now the ref count is one. Another object is created holding the same reference. So both are referring. The ref count is two. Get it? Okay. Now, when you're storing some other reference in it, the ref count is decreased by one. Here also some other reference I'm storing. The ref count is decreased by one. Now it has become zero. And the moment it becomes zero, this object is now eligible for garbage collection. So whenever the garbage collector is scheduled, whenever the schedule of that garbage collector is, it will collect all the objects whose ref count has become zero and it will put in free list. That time they are destroyed. So always remember instance variables when they are created, when the object is created using new operator. They are born now. When they are destroyed, when the object is eligible for garbage collection. Okay, and when it is eligible for garbage collection, when the ref count for that object has become zero. And where they get space on the heap, all instance variables will get space on heap. That is the rule. Okay, so I hope you got it. When they are created, when you create an instance. So remember, instance variables, they are also called as programmer controlled. Getting? They are also called as programmer controlled because it is in our will. It is in our will when to create that variable and when to destroy that variable. Getting? So totally it is in our control, right? When we want, we create an object no, using new. So whenever we want, we create an object using new means it is in our control. So always remember, instance variables, they are separate for each object. Getting? They belong to each instance, and each instance means each object. They are maintaining the separate state of each object. When created, when you create an object using new. When they are destroyed, when the object is eligible for garbage collection. And where they get space on heap. Always remember, they will get space on heap memory. Okay. And only the thing is, as they get space on heap memory doesn't have name. So it will give you a reference, and that reference you'll store on the stack. Get it? Just now I showed na, X and Y. So X and Y variable will be on the stack, but the where they are referring, that is on the heap. Remember, the key of your car is in the house, but the car is kept in the parking, like that. Means car you have parked in the parking. Where is the car? In the parking. The parking is your heap. But the key of that car is in your flat. So that flat is the stack part. Relate like that. Getting? Okay. And next thing, only one more point about this I have to tell you that if any instance variable, you're not explicitly initializing it. Okay. Like I created class cat. Okay. And then I'm writing integer height. And you're not initializing it here. You're not giving any value to it. Okay. String color. You're not giving any value to it. So if any instance variable is not explicitly initialized, you have not given any initial value to it, then it will have default value. Remember, it will never have garbage, means it will never remain uninitialized. It will automatically get some default value. What are the default values? I'll tell you. Like for integer category, it is 0. For character, it is backslash u 0000. For string, it is null. Okay. So different default values are there. I'll be telling you about that. I'll give you a table of it. Okay. So all the points related to instance are create to you. Instance variable means variables which are instance variables means variables which are belonging to individual instance of the class. That is variables which belong to individual object. They are never shared within the object. Every object will have its own copy. Okay? Because they want to store the state of each object separately. How to declare them? Like normal variable declaration only, which we studied in the last session. How to declare a variable. Type variable name semicolon. Or if you want, type variable name equal to value. Same syntax. But they are declared within the class body. Outside method, but inside class body. Then they become instance. Now, three things. When they are created, when the object is created using new keyword. When they are destroyed, when the object's reference are lost, meaning the object becomes eligible for garbage collection. When it is eligible for garbage collection, when the ref count becomes 0. And third, where they get space on the heap. But remember, they get space on the heap, but their reference is kept in the stack. Remember, cat money equal to new cat. So cat instance members are there. who are the cat instance member, height, weight, color, breed, they all will get space on the hip. But that whole object's reference is kept in money variable, and money variable is on the stack. Okay, so this way you have to remember. So I hope that part is clear. And the last point you have to remember, if instance variables are not initialized, if instance variables are not explicitly initialized, they won't remain uninitialized. They will not have any garbage. They will always have a default value. And what the default values are, I'll tell you. Like if it is reference null, boolean false, for character backslash u00, for floating point 0.0. So that are the default values. Okay? Okay? So the points are clear. We will just go through that. Then we will go to the second type, and then static type, and then local variable. Instance variables belong to objects. This point is clear. I mean, these are the variables which are separate for each object. They are never shared. It is a separate copy for every object. Okay. Each object gets its own separate copy. Means money will have its own copy of height, weight, color. Kitty will have its own copy of height, weight, color. I hope you understand it. Correct? And where they are declared inside the class body, but outside methods. Remember, outside method, but inside class body. Okay? Then created when the object is created. Means this is the timing. That's why we call them as their lifetime. So this is the time when they are born. So when they are born, when you create an object using new operator. So created when object is created using new operator. And new is the operator which is requesting to the VM that please reserve space on the hip. VM will reserve the space and VM will return the reference. That reference we collect in our reference variable, that is object variable. Okay. Then when they are destroyed, when the object is destroyed. But when actually we say the object is when it is eligible for garbage collection. And when it is eligible for garbage collection, when it has lost all its references. So object is eligible for destroying when it loses all its reference. Correct? I gave an example. X was referring to one object, Y also same object. So how many ref count? Two. But after some time I gave some other reference to X, ref count decrease. Some other reference to Y, again ref count decrease. Now from two it has become one, from one it has become zero. The moment ref count becomes zero, the object is eligible for garbage collection. Means it is eligible for destroy. Okay. And where instance variables get space on the heap memory. Okay. And they can have access specifiers like public, private, protected, and they can also have final. But if it is final, then automatic it converts to static. Huh? Means if you give final, then Java is so smart that it will automatic convert it to static. Because though it is final, when it is final, it's not going to change. So why to create separate copy of that variable which is not going to change? So it will keep it as shareable. It will keep it as static. So I'll tell you all that things. So you can give public, private, protected such access specifiers. And when you don't initialize any instance variable, whenever you are not initializing any variable, okay, then variable means instance variable, then they won't have any garbage. They will be automatically initialized to default value. So default value assigned automatically when not initialized explicitly. Okay. And later, once the instance variable come into existence, how you'll access them? Using dot operator. Correct? Like example, cat, e cat money equal to new cat. So instance variables are created on the hip, right? So as much memory is needed for cat instance variable, like there is one instance variable, height, color, breed, whatever. And then the reference is stored in money variable that is having a name. Whoever is having name will be on the stack. Okay? Now, using this money variable, which is holding that reference, you can access these instance variables using dot operator in context of that object. You'll write money dot breed, money dot color, money dot height. That way. All instance variable are accessed using dot operator in context of object. Means to access them, you have to have an object, remember. Without object reference, you cannot access. Means if you want to access your car which you have kept in the parking, you need to have keys of it. No? Without that, how you are going to access? You park the car in the parking area, but the key you have bought in the, you you come home and then you have put it on some key holder. So without that key, now again, how can you access it? You need that key to access that car. Okay? So all instance variables are accessed using dot operator. Okay, so that part is clear. See syntax like this: object dot variable. Okay, just simple illustration. I'm just trying to tell you, not a complete program because we will write some complete codes, but after understanding all the conceptual things. So see here, I've created class student with an instance data member roll number, one more instance data member name, one more of type float percentage. So you can see the declaration syntax is normal, which I told in the last session. Data type variable name, data type variable name. Optional, if you want, you can give value equal to value. Maximum, they can have here access specifiers like public or private or whatever. Correct? So dot means some more things can be there. So you have created a class. Now you're creating an instance of it. I'm creating instance. So how to create an instance? That is how to create an object, how to create a copy using new student round. The reference is returned, which we create store in our reference variable S1. Same way, one more copy you're creating. Okay. Then you're accessing their members. How you're accessing it? By dot operator. S1 dot roll number equal to 101 or S2 dot name equal to double quote Ram. Getting what I told in the previous slide, the same thing I'm trying to tell you. Pictorially, if you want to show on the stack, we have S1 variable, and when we wrote new student, it will allocate space for roll number, name, percentage, all three collectively, yeah, in a contiguous memory, 4 byte, then one more reference variable, then again 4 byte. So it will allocate space for all these instance variable. Then the reference is returned, which is stored in S1. Same thing when you wrote S2 equal to new student, again another copy, its references stored. So with this, is it clear that every copy means every object, every instance will have their separate set of instance variable because they are storing the state of each object separately. Every student will have different roll number, different name, different percentage. Getting or no? So both will have their own reference that is kept in S1, S2. And then later you access S1 dot roll number 100. So it will use that S1 in the context of S1, it will take roll number store 101. In context of S2, it will access name store run. Now you'll say, can I store roll number of S2? Obviously, guys, common sense. Yeah? Like, just as an example, I told you. You can store S1's name also, S1's percentage, S2's name, S2's percentage. Okay, everything is possible, right? Some more illustrations I'll tell you, but before that, we will complete with these three types. All the three types we will cover, and then I'll show you some small illustrations to clarify the difference between static instance and local. Okay, so instance is clear to you, right, guys? Quick confirmation.
Yes, sir.
Yes.
Okay, very good. Moving to the second type, that is static variables. Okay, now what are static variables? Static variables are shared between all the objects of that class. Means only one copy of static variable is created. Okay. Means they are not belonging to the individual object. Understanding? Like instance, they belong to individual object. So it is in separate object space. Every object will have a separate space. So instance variables will be separate for each object. Static is not like that. Static variables are existing only once in the memory, and all the objects of that class will share that one copy. Getting? But if suppose one object is modifying that single copy, the changes will be reflected to all other objects. Remember, if one object changes it, the changes will be seen to all other objects as well because they are not separate. It is only one copy. Getting? Now, where it is declared, same like instance, they are declared inside the class body, outside the method, inside the class body. Only you have to use separate keyword static to announce that it is a static variable. Getting? Like I'm creating class student. Okay. Here I'm declaring one variable integer roll number. Okay, or string name. So all these variables which I have declared inside the class body, but outside method, okay, and I'm not using any word static over here, then they are instance variables. So simple, common sense. Okay. But if I create any variable inside the class body only, outside method, but I'm giving keyword static to it. Like here, see, I'm writing string college. Now, college name will be obviously same for all the students. Like I'm storing 50 student information of the same college. So college name will not vary. So why to create college name as instance and keep it separate, whereas that college name is going to be same. So I'll put here like this static string college name. And here also, if you want, you can initialize it. Normal declare it. I told you, the general syntax is same, which I told last time. Type, name of the variable, optional, equal to value. Data type, variable name, and equal to value. The syntax is same for all variable. So if you want, you can give here ABC, whatever college name is. And if you don't want, it's okay. But you have given keyword static. Okay. So speciality of static variable is only single copy exists. All the objects of that class will share that single copy. If one object changes it, the changes reflected to all other objects. How to declare it? Declare it inside the class body, outside method by just using keyword static. Okay, ठीक And static variables also, if not initialized explicitly, if you're not initializing it, just semicolon, it will also have default value like instance variable. Just now I told if the instance variables are not initialized, what will be the value in them? No garbage, they will have default value. Same is the case for static. If static is not initialized, they will have default value. Okay. Now, how to access them outside class? How instance accessed? By creating object. Now, first you'll create object student S1 equal to new student, and then you'll write S1 dot roll number, S1 dot name. So here, what they say, to access any static variable, there is no need to create object also. You can directly access it in the class name context to avoid confusion. It is very much recommended that whenever you want to access any static member, directly access it in the class name context, student dot college. Correct? But it is allowed to access in the context of object as well. If you write s1 dot college, compiler won't complain. s2.college, it won't complain. But if you access it in whose context also, class name, then also it is because only one copy is existing. No? So if you write s1.college, s2.college, or student.college, all are accessing the same copy because it is static. Getting? But till now I didn't told you when they are created, when they are destroyed, and where they get space. Because today only I told you, all these variables are recognized on the three things only. When created, when destroyed, and where they enjoy their life or where they get space. So remember, statics are created at the time of code loading only. Getting? Means when the bytecode from the disk, bytecode will have its dot class file. So when the bytecode is coming from the disk into the memory in the code section, the bytecode is getting loaded. At that same time only, the memory for static variable is created. In some books, they say along with the code. Some books, they say in the data section. Okay, so it's up to you, whatever you are convinced, or tell that accordingly. Somewhere I have read that along with the code, somewhere they say in a data section. Okay, both are not contradicting or anything. Along with the code means same thing. Along with the code means where the code is over, after that, immediately the memory for that statics is there. Okay, so when the static variables are created at the time of code loading, okay, when the code is loaded, along with the code, statics get space. And when they are destroyed, when the program is terminated. Means in short, when your main is over, because the program life cycle start with main, and when main is over, the program is over, we say. Okay, so when your program is terminated, that time this memory is freed. Therefore, very big life who is enjoying a very big life? Statics. Correct? Why? Because they come at the very beginning, at the time of code loading. Means yet you have not created an object also. Therefore, sometimes no, in I've read it in certification books like statics exist prior to the object creation. Statics exist prior to the object creation. Comment on it. Correct? In interview, if they ask like comment on this point. Okay. So remember, irrespective you have created object or you have not created object of that class. Means you have created copies or you have not created copies. Who has already come into existence? Statics. Why? Because statics allocation and deallocation doesn't depend on the object. When the code is loaded, at that time only the memory for static is allocated. And when your code terminates, means your program terminates, that time the statics are released. So very big life who enjoy statics. So when statics get created at the time of code loading, and when your program terminates, they are destroyed. And in between, objects are created, which are created on the hip. Getting? So always remember, objects are created afterwards. When you load the code, after the code is loaded, then the code start executing. During execution of the code, you're creating objects. Therefore, before creation of the object, static exists and they remain in the memory for a very long time till the code doesn't terminate. Therefore, very big life who is enjoying static. Okay. So when statics are created at the time of code loading, okay, irrespective the object is created or not, you create object or you don't create. Who is there in the memory? Static. Okay, and when they are destroyed, when the program terminates. Okay, and where they get life, where they enjoy their life, like instance where they enjoy their life on the hip. Instance, when you create an object, they come in existence. When the reference lost, they are destroyed. And on the hip, they get space. Similarly, static gets space in this data section, or you can say along with the code. or in the method area, because your functions are there in the code. So in the method area only, who is getting the space? Static. Okay. And statics also, if not initialized, they will not have garbage. They will have default value. Okay. So all the points are clear to you related to static. What you'll remember, static variables are variables which are existing only once in the memory. All the objects of that class share that single copy. They are not separate for each object. Every object will share that same copy. If one object change it, the changes will be seen to others also. Getting? Okay. And how to declare it within the class body, outside the method, same like instance, only extra keyword static is there. Okay. And when they get space at the time of code loading, when they are destroyed, when the program is terminated, where they get space in the method section, or you can say along with the code, or in the data section, you can say. And if you not initialize it explicitly, no problem. Like instance, they are also automatically initialized to default. Okay, is it clear? And how to access them? Once you create a static variable within the class, how to access them? You can access it through object also, but you can access it directly by class name also. Okay, ठीक है? Now, static variables belong to the class, not objects, right? Static variables belong to the class, not object. They are not part of the individual object. Okay? See here. So static variables belong to the class, not object. Means all objects are going to share that single copy. Only one copy exists for all objects. How they are declared? As I said, inside class body, outside method, but using keyword static. All the objects later, afterwards, once the code is loaded, afterwards, if you're creating any number of objects, everyone will use the same copy. Getting? Memory is allocated how many times? Once. Okay. And where it will get the memory? In the method area, means in the code section. Methods means code only. No? In methods only you write logic, no? If, else, for loops, whatever calculations you write in method. So methods means code section. So in the code section only. Complete reference, if you read Herbert Shield, there they have mentioned that it gets space in the method section. But some document says there is a section called data section and all. But that data section is along with the code only. Okay. Then created when class loaded, means when they start their life, when they are born. So they are born at the time of code loading and destroyed when the program terminates. Agreed? Okay. Then, like instance variables, static variables will also get default value if you're not initializing them explicitly. If you don't give any explicit value to it, equal to, okay, so they will get automatic which value? Default value. I'm going to give the table of that default value, don't worry. Okay. And they also can have like instance variable, they also can have access specifiers like public, private, protected, default. They also can have final modifier. Okay. So I'll be telling you about this. Appropriate examples when we'll take, will come. And How to access them outside the class in another class? By dot operator only. So all static variables are accessed using dot operator only, like instance variable. Only there you're accessing in context of object, here you're accessing in context of class. But they say if your access is in context of object is also okay, but recommended is class. Just to differentiate it. Means in your code, it will be automatically identified. It is automatically recognized that as this variable is accessed in context of class, automatically we come to know this is a static variable. And if you are accessing in context of object, we automatically come to know that it is a instance variable. Correct? Like this, class dot where. But object dot where is also legal. Java says this is also legal, this is also legal. But what is recommended? The first one for clear understanding in the code. Means in your code, if you are writing the first type, we immediately recognize that this variable is a static variable. Okay, right? See, class student. Now, can you see? I've created, and the other members are there. Other data members will be there: integer roll number, string name, float percentage. But all three, I have not given static. So they are instance. They will be separate for each object, and they will come into existence only when you create object. But see here, college name, which is string, and it is static, and I have initialized also. This college name, only one copy will be existing. Remember, only one copy. And when it will come in existence at the time of code loading, you create object or you don't create. You create student object or you don't create. College name has come in existence. When the code was loaded, that time only the space for this is allocated in the method area or in the data section. Okay. And it will exist till the code doesn't terminate. And how you will access it? Good practice, class name dot student dot college name. Okay, see here. I created two objects. Through object also, if I access, it will print the same thing. Okay, and actually I was supposed to write S2, and through class name also. Okay, as I copy pasted, I forgot to write S2 over here. Okay, so if I'm accessing college name via object or through class name, still they all are accessing the single copy only, and all three will print the same thing. Okay, now till now we haven't discussed about this statement, but now at time being, just remember it's like in Python we have print, or in C++ we have cout, or like in C we have printf. Same way in Java we have system.out. But we will be discussing in detail. Huh? Okay, okay. So this part is also clear. I'm going to give demonstration. Huh? Today I'm just covering with the conceptual thing, and now after this I'll give you skeleton codes also. In JShell, I'll write some small codes and I'll show you the difference between all this. Okay. Quickly, we will cover up with the third part, that is local variable. Okay. Now, what are local variables? Local variables are variables which are declared inside a block or inside a method. Getting? Whenever you create any variable inside any method or inside any block, block means group of statements. When you are creating a group of statement, then in Java we call it as a block. And how do you designate a block? By open brace, close brace. Getting? Open brace, close brace. Now, this open brace, close brace can be of a loop or it can be of a if statement, like if it is a if statement. So it is beginning of that if block. So immediately inside this, if I'm creating a variable, Okay, inside this block I'm creating. So this becomes a local variable. Okay, or if it is a while loop, so inside that while body, or you're starting a for loop. So in the beginning of that for loop only you're writing int I. Okay, so these are local variable. Okay, or you're writing any method, like you're creating any method void main. Okay, and the body of that method. Method means you're understanding now, a function, and function is what? A block of code which performs some task whenever called. It returns also something. It takes some value from the outside world. Okay. When we have discussed about procedure-oriented programming, that time I have told you all this. Procedure-oriented and object-oriented, right? So function or a method is the block of code. It is having name. It is performing some task. When it is performing the task, whenever called, it may return also something. You can pass value to it. Okay. Now, inside this body of this method, in the beginning, if you're creating any variable. Now, can you see here also the declaration is same syntax which I told last time. Type variable name semicolon or type variable name equal to value. Same syntax for all three. Okay, so whenever you create any variable inside the body of any method or any block, while block or if or switch, then it becomes a local variable. Okay, and remember for local variable, you're not allowed to give public or private or protected or static. You can give final to local variable, but other things are not allowed. Local variables cannot have access specifiers like public, private, protected. They cannot have modifier like static is wrong. You cannot give it to local variable. And local variables are also called as automatic variable. In some books, they have mentioned that too. Automatic. Okay. Now, why we call them as automatic? I'll tell you. Okay. But first, I hope it is clear what are local variables. Local variables are variables which are declared within the block. So it can be a simple while block or a if block or a for loop block, or it can be a method block, a block body of your method. So inside the method, when you create a variable, they are called local variable. Getting? And local variables are created at the entry of that block. Entry of the block means when the method is called. Now, when that main is called, when main is getting called, the control will go to that main, wherever that main is. So it is doing entry in that main. So when it is doing entry, all the local variables will get created. And when main gets over, it will come back. So when it is over, they are destroyed. So their lifespan is when the block entry, when you are entering in that for block or in that while loop is started, for loop starts, or that method is called. So at the entry of that block, local variables are born. And when the block is over, they are destroyed. Okay. And they get space on stack. And see why stack is only appropriate for local variable. Because the calling sequence is in that manner. Getting? The methods are called in a LIFO manner. See here, if you have created a variable, sorry, a method, sorry, method main, okay, and inside main there is a call given to foo. Foo is the word which is not having any meaning. It is just a pun word. Like in Marathi, we have Bandya Pindya. So Bandya Pindya is not having any meaning. They are just fun words. Okay. Similarly, foo is there. Okay. And foo, inside foo, there is a call to bar. Okay. and then we have somewhere bar. Okay. Now you can see the calling sequence is like that. First who is called main. Okay, main is running. And foo is called. So main suspends its exit, not stop, suspend. It is not stopping. For time being, it is suspended and foo becomes active. So it goes to foo. So main is temporary suspended and whose execution start? Foo. Foo becomes active. It comes inside foo and foo is running. And foo gives call to bar. Now foo is suspended and the control group comes to bar. Bar becomes active. Now it is running bar. Now in this case, who will complete first? Main or bar will complete? Obviously bar. The latest one is going to complete first. When bar gets over, it come back. Then who is resumed? Temporarily who was suspended? Foo. Temporary foo was suspended. Whose execution is resumed? Foo's execution is resumed. And when foo get over, it come back to main and main execution resume. So if you check it in the stack manner, first main, when main gave call to foo, main suspended and foo becomes active. When foo is executing, it gives call to bar. So bar becomes active and foo becomes suspended. Now in this sequence, tell me, first main was called, then foo was called, then bar. But completion first bar is done, then foo and then main. So as the calling sequence is in a calling and termination, call and termination is in a LIFO manner. Obviously, the local variables of all the functions, main local variable, foo local variable, bar local variable, will be kept on what? Stack only. Getting? So they are created at the entry, they are destroyed at the exit, and where they get the space? On the stack. Okay, local variables, declaration syntax is same, type, variable name. And if you want, you can give initial value. They can be primitive, non-primitive, no problem. But they cannot have static modifier. They cannot have specifiers like public, private, protected is not allowed. Okay, where when created at the entry, when destroyed at exit, and where they get the space on stack. And this allocation, deallocation is not in our control, guys. It is automatically created at entry and automatically destroyed at exit. That is the reason they are also called as automatic variables. Okay. And one last point about this, I have to tell you that if local variables are not initialized explicitly, okay, if local variables are not initialized explicitly, see here, this is a local variable and I'm not initializing it. This doesn't follow the rule of static and instance. What I told during static and instance, static variable and instance variable, if they are not initialized explicitly, they have default value. This is not true for local variable. Local variable, if it is not initialized, they will have garbage. But actually Java doesn't use word garbage. Instead, in Java literature, they call it as uninitialized. Local variables, if not initialized, they will remain uninitialized. Actually, it is garbage, but you should call it as uninitialized. And the speciality of Java is when we saw features of Java, that Java is robust and secure. This point is contributing it. Java is robust and secure language. It will not allow you to use any variable which is uninitialized. Understanding, guys? Like suppose I'm creating one more variable j, and later in the code I'm writing j is equal to I plus 20. Now for j it won't complain. Why? Because j is getting initialized. Something is going to get stored. So compiler doesn't complain for J, but it is complaining for I. It is saying you're using a variable which is uninitialized. What Java says, the point where the variable is declared till the first use where you're using it, as many paths are going there, as many execution paths are reaching there. In that path, somewhere the variable has to be initialized. Without initialization, you cannot use it. See here, the variable is declared, but it is not having any initial value. You're directly trying to use it. Correct? I'll give you a demonstration. Don't worry, everything practical demonstration I'll give. So when you are declaring a variable and directly using it, it is uninitialized. Java compiler will throw a error, compilation time only. It will give a error, variable J might not have been, variable I might not have been initialized. We see how robustness it is. Whereas in C++ or C, what it will do, it will take garbage value. Garbage plus 20 is garbage only. Anything you add in garbage is garbage only. Okay. So garbage plus 20 will be garbage and garbage is stored. Such thing will never happen only in Java. Java says if you are using any variable, then at the point where it is used, before that, somewhere it is initialized. Otherwise, it will not allow you to use it. Getting this point? It will throw an error only. Variable I might not have been initialized. Okay. So that is the rule. See here. So quickly, we will discuss about this local variables also. Variables declared inside methods or constructors or blocks. Constructor is also a method only. And whatever normal methods like class cat. So I'm writing void set data or void meow or void eat, void sleep, void run. So method, constructors or blocks, normal for block, while block, if block, okay, are called local variable. Declaration syntax is same. Type variable. If you want, you can give value to it. Accessible only within that block. Now, obviously, they are created inside the block. So obviously they are accessible only within the block. Outside the block, you cannot access, means its lifespan or its scope is only restricted to that block. They are born when the method is called. At the entry of that block, they are created. And when the block is over, that is exit of the block, they are destroyed. So within that block only, they have their life. They are going to enjoy their life between that entry and exit. Okay. So accessible within that block. No default value. Means if you have not initialized it explicitly, they will not get any default value. They remain uninitialized. No default value when not initialized explicitly. But what is the specialty of Java? It will never allow you to use which variables? Uninitialized variable. It says when you declare a variable and the first place where you are using it, between that somewhere the variable has to be initialized. Okay, must be initialized before use. And if you are using it directly without initialization, it will throw a error, a compile time error. Okay, and when they are born at the entry, when they die at the exit, and where they get space on the stack. Why stack is only appropriate? Because they are calling sequences that way only. No? Is they are they called in a LIFO manner? Main give call to foo give call to bar. So who completes first? Bar, then comes to foo back, then foo complete, then come back to main. So as their entry and exit is in the LIFO manner, best place for storing these variables are stack. So created entry, destroyed at stack, exit, they get space on the stack, okay, and they cannot have all such things, public, private, protected, okay. Also, copy paste I did, also static, not final. Please make change as I copy paste. Final can be there. Local variables can have final, but local variable cannot have such static modifier. and they cannot have such public-private protect, which instance and static can have. Okay, then quickly we will discuss about this. That is the default values, and default only are for instance and static variables, sir, remember. Okay, see here. So if it is a Boolean variable, the default is false. If it is character, then it is having Unicode 0. In any of the integer category, it will have 0 or 0L. Floating point category 0.0, 0.0, float or double. And if it is a reference, reference means object. See here, means I'm creating an object of cat, that is money. But I haven't initialized it. I didn't wrote equal to new cat, only this much. So what will money contain? Null. Because it's a reference variable. Is money a reference variable? Yes, money is a variable of type cat. Cat is a user defined type. User defined variables are always reference variable. They are called as object variables or reference. Okay. So I hope it is clear. Now for today, as there is a lot of noise created, I'll try to see tomorrow this won't happen. But so all the three things are clear. So quickly, can anyone tell me quickly, just to recap? Okay, just tell me when created, when destroyed, and where they get the space. All three. Someone unmute and just tell about instance. When instance are created, when instance are destroyed, and where they get the space. Someone. Then someone else unmute and tell me about static. When they are created, when they are destroyed, and where they get space. And someone else tell me about local. Chalo, quickly. I'll be happy to hear from your side. Anyone. Don't be afraid. Just tell. Only the three things you have to tell. When they are created, when they are destroyed, and where they get space. Simple talk it is. Simple answer. Chalo, quickly. Who is going to unmute and answer? Last time also I gave a message in the group. I thought by seeing that message you will be little bit serious now. Still the same thing. 5 and 6 people have joined. 26, 27 students have taken admission. 200 rupees is a peanut na, for you, right? Chalo, who Shamali? Chalo, Shamali will answer because every time she only takes the responsibility. Is Shamali there? No, yes.
Yes, sir, I'm here.
So just tell me about just instance. Tell me instance when they are created. When?
Instance when created a class, it's created in class.
Nini, I'm telling when they come into existence. When instance variable get memory. When they get memory. When the object is created using
Oh,
new.
yeah, when object is created, yes.
When the object is created using new, they get space. Then
Yes.
when they are destroyed,
They are destroyed when object is destroyed.
meaning when the reference is lost.
Lost, yeah.
Getting? When the reference is lost, the ref count becomes 0. When the object becomes eligible for garbage collection, they are destroyed. And where they get space, instance gets
Uh,
space
in heap
in which
memory.
in heap memory. Very good. Someone else quickly tell me about static, when they are created, when they are destroyed, and where they get space. Quickly. No, someone else, please take efforts. You want job. How I'll recommend you people. When you will quick, when you are continuously active in the session, then I remember, yes, this person is active. He always answers. So obviously, I'll give that recommendation to HR people. I'll say that no, this is very good student of mine. Please see to it, right or no? But if you don't answer only, then how I'm going to take efforts for you people? Chalo, Garb is there, I guess. Abhishek is there. Siddhant is there. You just have to tell when static are created. Static
Yes, sir. I
created.
will tell about static.
Okay, tell.
Static is created when class loads, and it gets
Yes,
destroyed when program gets terminated.
right. Very good.
And
And
it is
where it?
sto-
Hmm? Yes,
it
yes, speak.
it is stored in method area like in classes or data, code or
You call
data
it as a code section.
or
In the
data.
code section, along with the code only. Generally,
Yeah.
they call it as along with the code, or you can call it as a data section where statics are created. Very good. Clear? Very good. And what about the third thing, that is local variable? Can anyone else now? Someone else answer. Answer, guys. At least today, two people took efforts of answering. Think that it is your offline class only. I'm standing in the class, you're sitting on the bench. Same way. You imagine that way only. In the future, everything is going to happen online. Our Prime Minister has already encouraged. He's encouraging, he's not enforcing. He's encouraging, don't take gold. He's not saying you don't buy only. Remember, we are not in North Korea, right or no? Just imagine if you would have been in North Korea, the king of North Korea, he just enforces the rule. He doesn't appeal to people, he enforces, right? So thank that you are staying in India. But still we people will keep trolling him, right or no? There might be some reason behind it, now why he's asking for doing all such things. Don't do foreign travel, or don't try to do online work. So try to find out why what might be the reason behind it, right? Huh? Just don't get influenced by the social media. Okay. Anyways, can anyone third person tell? Chalo, quickly, girls. There are so many girls also attending. Chalo, Tanishka is there, I guess. Just have to tell me when locals are created, when they are destroyed, and where they get space. Chalo, quickly, it takes so much time. I have to uh, motivate you to answer. This should not happen. You all are not 8th or 9th, 10th standard student. I guess you're learning full stack means you're already in graduation or beyond that. No, others are also there, Priyanka. Chalo fast. So locals are created when? Is it so much difficult to unmute and answer?
When any method or construct is created or block in a particular block.
Means sorry, locals are created within the block. So when we enter in that block, they are created. And when the block is over, they are destroyed.
Destroyed.
And where they'll get space on the stack
Stack.
section. Correct? So locals get memory on the stack. Instance get memory on the heap. And static get memory in the data section or along with the code or in the method area, you can call it as. Okay? Good. So next time I'll show you the differences. And remember about their initialization. Static and instance. If not initialized, they will have this default value. But local, if not initialized, it will remain uninitialized only. But the speciality of Java is you cannot use uninitialized variables. It will throw a error. So I'll give you demonstration of all that things. The default values. I'll print and show you the default value, or I'll try to access the local variable without, then I'll show you the error. Okay, so all that things we'll discuss. And then a very new topic we have to start, that is operators. Some MCQs will solve, and then operator is an exhaustive topic. It will take a long time because lot of operators are there in Java. So all that operators one by one we will cover. Okay, so for today I'll take pause over here only. Thank you all of you.